I'm Mary Swarnalatha, working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the random process and correlation function corresponding definitions. So first, define random process. So what is a random process? A random process is a time-varying function that assigns the outcome of a random experiment to each time instant. Or else simply you can say that. So what is a random variable? First we'll see the definition. What is a random variable? And what is sample space? The list of all the possible outcomes when the experiment has been conducted is called as what? Sample space. And what is a random variable definition? For each element in the sample space, if you assign a real value for each element in the sample space, if you assign a real value, it is called as what? Random variable. Then what is random process? So for this random variable, so what you are assigning? You are assigning a time instant. If you are assigning a time, if you are including a time variable, then it is called as what? Random process. So what is a sample space? Nothing but collection of all the possible outcomes when the experiment has been conducted. And what is a random variable? A random variable is a function of the sample space elements, or else is nothing but what? For each outcome in the experiment, if you assign a real number, it is called as what? Random variable. Therefore, it is a function of what? The sample space elements. And what is a random process? So, it is a random process for this random variable. So, it is a random variable x of s. If you include a time instant, a time function, it is called as what? Random process. So, it means for the sample space, each element, you have to assign a real number and you have to assign the time variable. It is called as what? Random process. Next, what are the classification of random process? So, having totally 4 types of random process. They are continuous random process, discrete random process, continuous random sequence and discrete random sequence. So, define continuous random process. So, a continuous random process is one in which the random variable x is continuous and time t can have any continuous values. It means, for example, if you take a random process x of s comma t, simply can represent by x of t only. Then, when can you say that this random process is continuous? So, if the random process, so I told you that the random process is a function of 2 variables. One is what? Random variable and the other one is what? Time. So, if the random variable nothing but, let us say here x I had taken and the time here t is nothing but time. So, if both these random variable and time are continuous, it is called as what? Continuous random process. Next, what are the examples of continuous random process? The examples of continuous random process are what? Thermal noise in the conductor, short noise in transistor, and wind velocity. These are all examples of what? The continuous random process, because continuously the values are changing. That's why these are the examples of what? Continuous random process. And define continuous random sequence. So to define continuous random sequence, in a continuous random sequence, the random variable x is continuous but the time is discrete. Here, what is a continuous random sequence? So you have to remember 2 things. The first one is continuous is nothing but the type, if it is continuous, is nothing but the random variable. The random variable is continuous. And if you say sequence, it means time is what? Discrete. If you say process, then the time is what? Continuous. If you say discrete in the random process, then x is nothing but discrete here. So here continuous random sequence. So continuous is nothing but what? The random variable x is continuous. And what is sequence here? The time t is what? Discrete. So this is the definition of what? Continuous random sequence. So next one is what? How can you obtain the continuous random sequence? So what is a continuous random process? For continuous random process, the random variable x is continuous as well as the time t is also continuous. Next, for continuous random sequence, for continuous random sequence. The random variable is what? Continuous, and t is what? Discrete. Now, how can you obtain this continuous random sequence from this continuous random process? Here t is continuous and here t is discrete. How can you obtain? How can you convert continuous time to discrete time? By using what? Sampling. Therefore, by sampling the continuous random process, we can obtain a continuous random sequence. Next one is, what is discrete random process? So, a discrete random process is one in which the random variable x is discrete and the time t is continuous. So, this here definition: discrete random process. So, whenever I say process, the t is nothing, the time is what? Continuous. So, whenever I say discrete, nothing but discrete random variable. So, the random variable is what? Discrete. The random variable here discrete. And the time here t is what? Continuous. And next one is, give an example of discrete random process. So, discrete nothing but the random variable discrete. Process nothing but the time t is continuous. So, a random telegraph process is an example of what? Discrete random process. Because if you take at any time instant, the telegraph signal takes only value 0, 1. Nothing but the random variable is taking only 2 values, 0, 1. But whatever the time, if you take any time instant, it is continuously or it is taking the values continuously. Therefore, here t is continuous and the random variable takes only 2 values, 0, 1. Therefore, it is nothing but what? Discrete. Therefore, the random telegraph signal is an example of what? Discrete random process. Next, what is the difference between random sequence and random process? So, I told you that sequence is nothing but time is what? Discrete. So, process is nothing but what? The time is what? Continuous. There is a difference between sequence and process. So, next one is, what is stochastic behavior? Stochastic is nothing but what? Randomness only. So, wherever we have the randomness and uncertainty, nothing but what? Stochastic. And the other name for random process, nothing but what? Stochastic process also. Next one is, what is the difference between random number and random variable? So, what is a random number? Nothing but what? A random number, nothing but what? Taking a random sample from a population. Nothing but what? Random number. For example, if having so many numbers, from this randomly you can pick any number from that. Nothing but randomly you are choosing the number from that population or from that set. It is called as what? Random number. And what is random variable? A random variable is a function that maps all the possible outcomes to a real number. That is nothing but what? Random variable. Therefore, random number is different and random variable is different. So, number is nothing but what? Selecting randomly from a population. Nothing but or from a set of values is called as what? Random number. And what is random variable? It is a function that maps all the possible outcomes to a real value. Nothing but what? Random variable. Next, what is deterministic random process? The name itself saying that deterministic nothing but what? The future values of the sample function can be predicted from its past values. It is called as what? Deterministic random process. Next, what is non-deterministic random process? The name itself saying that what? Non-deterministic, non-determined. So, a random process said to be non-deterministic if its future values of an sample function cannot be exactly predicted from the past values. So, from the past values, it is called as what? Non-deterministic random process. So, if you take almost all the natural random processes are non-deterministic random process. For example, the best example for non-deterministic random process nothing but what? Noise signal. Next, define stationary random process. So, what is stationary random process? If all the joint density functions the random process do not depending upon the shift in the time, it is called as what? Stationary random process. Since the time it is not depending upon the time is fixed here, the mean values are fixed. They are not depending upon the time, but they are depending upon only on the time difference only. So, this is the definition of what? Stationary random process. Next, define nth order stationary random process. So it is nth order stationary random process. A process said to be nth order stationary if the joint distribution function of nth samples is independent of the shift of the time origin, or simply can say that if its nth order density function does not change with time. Nothing but what? For example, if I take x1, x2 and so on xn. So these are the n random variables that depend on the random process. If we take a random process x of t, and this random process, how many random variables are defining? We are defining n number of random variables x2 and so on xn by keeping the time constant t1, t2 and so on tn. Now what is a nth order stationary random process? If its nth order density function does not change with a shift in the time origin. So nothing but what? x1, x2 and so on xn, comma. If the time is shifted also, the density function should not change. Then it is called as what? Nth order stationary random process. Next, define the distribution function of a random process. So for example, if you take x is a random variable, what is the distribution function of that random variable? Fx of x is nothing but the probability of the values such that the random variable takes up to small x is called as what? The distribution function of the random variable x. Now if you take a random process x of t, then how can you define the distribution function of a random process x of t? Nothing but fx of. So in order to define the distribution function, you have to keep the time as constant. So for this random process, if you keep the time t as constant, t equals t1, then you are getting the random variable x1 here. So fx of x1 comma t1, nothing but what? Probability of x of t1 is less than or equals to x1. So what is x of t1? X of t is a random process. So here t is any time. If you fix that time t equals to t1, then you are getting a random variable x1. So like that you can define the distribution function of a random process by keeping the time as constant. Next, define the density function of a random process. The differentiation of distribution function of a random process at a fixed time is called as what? The density function of a random process. So fx of x comma t1 is nothing but what? The differentiation of the random process by fixing the time equals to t1. So it is called as what? The density function of the random process. By fixing the time, you can fix either at t equals to t1, t2 and so on. At any time you can fix the time. So it is called as what? Density function of the random process. Next, define independent random process. Two random process x of t and y of t are said to be independent if all the possible random variables generated by sampling from x of t are independent of all the random variables generated by the sampling from the random process y of t. What does it mean? Well, first we'll go for the concept of random variable. How can you say that two random variables x and y are independent? If u of xy is equals to what? U of x into u of y. Then you can say that the two random variables are independent. Or else can say that fxy of x comma y is equals to what? Fx of x into fy of y. The same concept now will apply to the random process also. So consider two random process x of t and y of t. Now for this random process, you are defining the random variables like x1, x2 and so on xn by keeping the time constants t1, t2 and so on tn. And similarly, you are defining n number of random variables in the random process y of t by keeping the time as constant, let us say t1 dash and so on tn dash. And then how can you say that the two random processes of universe have to be independent if all the possible random variables generated from the random process of t are independent from all the possible random variables defined from the y of t. It means fxy of x1, x2 and so on xn, y1, y2 and so on yn. How do you get the random variable x1? By keeping the time t1. Similarly x2 from t2 and so on tn. And how can you obtain y1? By keeping the time t equals t1 dash at random process y of t. and so on up to Tn dash is equals to what? Fx of x1, x2 and so on xn. So T1 and so on Tn into Fy of y1, y2 and so on yn. So how can you get those random variables? T equals to T1 dash and so on Tn dash. Then the two random process of T and y2 is said to be what? Independent random process. So define first order stationary random process. So a random process x of t is said to be stationary to order 1 or first order stationary random process if its first order density function does not change with a shift in time. It means what is the first order density function? Fx of x1 comma t1 is equals to what? Fx of x1 comma t1 plus delta. It means the first order means you have to take only one random variable. You have to define only one random variable and the random process x of t by keeping the time t equals to t1. Then the corresponding density function is called as what? First order density function. So if its first order density function does not change with the shift in time, then it is called as what? First order stationary random process. Similarly, define second order stationary random process. So random process x of t is said to be second order or stationary too if a second order density function does not change with the time. So second order means how many random variables are defined in the random process x of t? You have defined two random variables on the random process x of t. So at t equals to t1 and t2. Then what is second order density function here? Fx of x1 comma x2. It means we are defining two random variables at t equals to t1 comma t2 is equals to what? Fx of x1 comma x2. So t1 plus delta and t2 plus delta. It means here previously the time is t1. Now it is shifting with time. So even though it is shifting time, the density function should not change. Then it is called as what? Second order stationary random process. And define wide sense stationary random process. A random process x of t is said to be wide sense stationary or least sense stationary if its mean is constant for all the values of t and its auto correlation function is a function of only the time difference. It means out of all the conditions, if it is satisfying only two conditions. The first condition, the mean of the random process should be constant for all the values of t. And what is the second condition? The auto correlation function of the random process should be a function of only the time difference. So t2 minus t1. Rs you can write down Rx of t comma t plus tau is equals to Rx of tau. So then if the two conditions are satisfied is called as what? A wide sense stationary random process. Next one, define jointly wide sense stationary random process. Jointly means you have to consider two random process x of t and y of t. Then the two random process x of t and y of t are said to be jointly wide sense stationary if their means are constant for all the values of t, and second one is their cross correlation function should be a function of only the time difference. What are the two conditions? The first condition is the mean should be constant. It means what? E of x of t equals x bar and E of y of t equals to what? Y bar for all the values of t. It is constant. It should not change with time. And second condition is what? Is cross correlation function. Nothing but Rxy of t1 comma t2 is equals to what? It is a function of only the time difference. So t2 minus t1. Then there are the two random process of wide set to be or jointly wide sense stationary process. Next, define time averages. So what is the time average? So expectation is nothing but what? Statistical average. So expectation nothing but what? Statistical average. So and the time average has been denoted with the symbol what? AR. So the average value of the sample function x of t taken over all the times is called as what? Time average of x of t. So it is also called as what? Mean value of x of t also. So how can you calculate the time average of, for example, x of t? Nothing but what? Limit t tends to infinity integration minus t by 2 to t by 2, or you can take from minus t to t. So 1 by 2t integration minus t to t. So x of t into tt. This is called as what? The time average of any function. Next, define ergodic theorem. What is ergodic theorem? Ergodic theorem states that for any random process x of t, all the time averages are equal to the corresponding statistical averages with probability 1. Then it is called as what? Ergodic theorem. What is ergodic theorem? It states that all the time averages of the sample functions are equal to the corresponding ensemble or statistical averages. Then it is called as what? Ergodic theorem. Next, define mean ergodic. So, mean is nothing but what? The mean, the time average is equals to what? The statistical average with the probability 1. Then it is called as what? Mean ergodic process. Then what is time autocorrelation? So, the time autocorrelation function of a random process x of t is nothing but what? It is a measuring the similarity between a given time signal x of t and it's a lagged version of signal, nothing but what? It is a time autocorrelation function. So, if you take a random process x of t, then the time autocorrelation function nothing but what? T comma t plus tau. So, it's a random process and its lagged version nothing but what? X of t plus tau and x of t. So, measuring the similarity between these two signals is called as what? The time autocorrelation function. And similarly, time cross is nothing but you have to consider two different random process and you have to consider measuring the similarity between one random process and the lagged versions or delay of another random process called as what? Time cross correlation function. Next, define autocorrelation ergodic. So, what is ergodic? Nothing but the statistical average equals time average. Then what is autocorrelation ergodic? If time autocorrelation equals to the statistical autocorrelation, it is called as what? Autocorrelation ergodic process. So, next, similarly, what is the defined cross correlation ergodic process? If its time cross correlation function is equal to the statistical cross correlation function, then it is called as what? Cross correlation ergodic process. Next, define autocovariance function. So, what is the covariance for two random variables x and y? So, Cxy is equals to what? Expectation of x minus x bar into y minus y bar. Then what is autocovariance? Auto means you have to consider a single random process and this random process you have to define two random variables at the time instance t and t plus tau. Then what is autocovariance? X of t comma t plus tau is equals to what? Expectation of x of t minus x of t bar and x of here in place of y I take what? X of t plus tau into x of t plus tau bar. Nothing but what? The autocovariance function. Similarly, cross covariance means you have to consider two different random processes x of t and y of t. Then what is the cross covariance between those two random variables? Expectation of x of t minus x of t bar into y of t plus tau minus y of t plus tau bar is nothing but what? Cross covariance function. Next, define Poisson random process. What is a Poisson random process? A Poisson random process is a discrete random process which represents the number of times the event has been occurred as a function of time is called as what? Poisson random process. What is a Poisson random variable? That is used for counting applications. The number of times it has been occurred. For that Poisson random variable, if you include the time function, it is called as what? Poisson random process. So, in the today's lecture, we have discussed about the random process definition and then stationary random process, ergodic process, and then we have seen the definitions of autocorrelation, cross correlation, autocovariance and cross covariance. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.